I won't start with the video from Gil. We'll get to that as we progress. So first of all, I'd like to say that it was great yesterday, and thank you for all the people that talked and said such nice things about my father. I'll just tell you a small story. A year ago, we were sitting in Berkeley with Boaz, and I was talking to them about Ogden, which is probably the most famous psychoanalyst alive today. And Boaz asked me who he was, and I told him, he's this really famous guy, and he asked me, oh, so like your father? And I said, well, you know, no offense, but I think psychology is a bit of a larger area than theoretical computer science, so just to put things in proportion. Yeah, so now that we got that settled, we can continue. So I assume a large person... okay, so now we'll go back to Avi. So I assume a large percentage of the people here know me, and for those who don't, I'm Einat. I'm Avi's middle child and only daughter, and the mother of his only granddaughter, but we're hoping for more. For those who personally know him and all the people that were present yesterday and through the talks, I think it's clear how much he loves small kids and what a special relationship he has with Tamal. It's so special that he sometimes gets confused and thinks he has two daughters, which makes me furious, but with that said, I'm very happy to have such a charming and lovable person in her life, and I think it's great for her to have him. So I assume even among those who do know me, the fact that Gil asked me to replace him in this talk is quite odd. As a child, I dreamed to be a mathematician. I think many of the people here knew me when I was small, and when I was asked what I want to be when I grow up, I always said a mathematician. But the thing that scared me the most about this was the fact that part of the job is standing and talking in front of people. And yet I find myself here today speaking about a subject that's so far away from my current interests and career path, and actually standing on stage and giving a lecture. Okay, and on top of that, I'm stepping in very big shoes. So Gil is not only a great mathematician, as you all know, he is probably the best comedian I know. Gil is one of my father's and family's best friends, and I can recall endless nights we spent with him laughing uncontrollably and crying our eyes out. So I hope I will manage to pass some of his spirit today in this talk, and in order to do so, part of the lecture is taped, so you'll actually see Gil on stage for parts of it, and I made sure not to make any editing of the spelling, so you will sense Gil through the lecture. And I'd like to take a few minutes to explain why Gil asked me to replace him today. So, as my mom mentioned yesterday, my parents met at the end of their BAs in a math problem-solving course. And having two brilliant parents with a strong mathematical orientation and education in our upbringing, there was always an expectation that we would also be successful in this area. As I was unexpectedly preparing for the talk, and with the help of Eyal, we decided to study this function, a function describing our mathematical capabilities. So the input to the function is any of the Wigderson kids, and the output should be our mathematical success index. And as we discover, this function turns out to be NP-complete and thus cannot be computed. So later we found out that we could very accurately estimate it when taking into consideration our interaction with Gil. Due to the limitations of time, but mainly because this discussion will be too technical for the audience, I won't go into the details, but you'll have to believe me, it's correct. And another interesting observation we came up to is that our mathematical success index is the inverse of our laziness index. Okay. Whoops, no. Oh, no, sorry. Okay. So I would like to start off with the tale of two non-mathematical kids. And we'll start with Eyal, my older brother. As expected from a Wigderson, he went to the highest achieving math course in preparation for his high school matriculation exams. And as the laziness kicked in, he thought about making his life a bit easier by changing to a lower level. He came up to our parents one day with this great idea he had, and for the first and only time during his schooling years, they stood on their back legs and rejected the idea. And so he stayed and finished his coursework. Actually, he finished only a small part of his coursework, so despite getting a very high grade in the final exam, his grade wasn't so high at the end, but that's because of the laziness. And after he finished, our parents tried to convince him to do a math thesis as part of his high school matriculation exams. And he wasn't very excited about the idea, but decided to give it a try, and he thought, how could he make his life, how could he get the best out of this experience? And after brainstorming, he decided that Gil will probably be the best candidate for supervising this. And it took them a while to arrange an appointment, but finally they did, and Gil gave Eyal some reading material, and soon the laziness kicked in, and he decided to fill his free time with hiking and climbing and other exciting things. And then during his BA in biology, he did make one more attempt in math, and he took Ehud's Discrete math course and passed with an astonishing grade of 56. So this is Eyal, and as you can see, his normalized laziness index is 1. And then we move on to me. So I studied 9th and 10th grade in Princeton. These were extremely terrible years for me. I was bored and I hated every minute of it. And so I decided, with the push of my parents, to take my Israeli math matriculation exam externally. And days of quality time with my dad studying for these exams were definitely the highlight of these years. Seriously, that was the most exciting thing I did during these 2 years. And then I returned to Israel in 11th grade, and I didn't have much classwork to do, so my parents convinced me to do a math thesis. And independently, I took the time thinking, how can I make the best out of this experience? And obviously, I came up with the same idea as my brother and decided to ask Gil to supervise me. So I actually did end up doing a high school thesis, and this is the reason why Gil asked me to replace him today. He wanted to talk about our work together. Actually, it turned out to be quite a challenging experience, and despite Ehud making a fool of me yesterday, I would like to say thank you for helping me with this, and my father, of course, for hours of helping. Gil wasn't as supportive as expected, but that's okay. And then I actually kept on dreaming to be a mathematician, and I started my BA in math. And after 2.5 semesters and 2 not so successful attempts in Ehud's discrete math course, I decided to drop it, and this is how I became a clinical and developmental psychologist. And I think this is the only work in the world my dad might have enjoyed as much as being a theoretical computer science, so because you get to play around with kids all day. So this is me. And then we move to Yuval, and there's really not much to say in this context about Yuval, only that I'm very proud of him, and I know he brings a lot of satisfaction to my parents, so. Yes. And just one last interesting observation in this context is that the ratio between our laziness indexes is exactly the ratio of our ages the day before Yuval was born. So this probably explains everything. And now to Gil's abstract. Here you go.
Avi is a wonderful mathematician, full of imagination, vision, and power, equipped with a special access to a hidden resource, the theory of computing. Witnessing Avi and fellow theory of computing people changing the world was always a great pleasure. My lecture will touch on happy days with the Wigderson of friendship, joint ventures, collaborations, and debates, with special emphasis on discrete geometry and games.
So, Happy Days Part 1 is Gil's story, and we start at BA before Avi. So Gil was born in 55 in Tel Aviv. In 58, he moved with his family to Jerusalem, and between the years of 1970 and 1983, he got interested in math and met many people that many of them are sitting here today, Noga, Nati, Anel Shalev, and so on. And he actually TA'd Noam Nissan and Muli Safra during their studies in linear algebra. And Muli wanted to study physics, but turned out he was too lazy to do the paperwork himself, so he copied Noam's, and but they both became great computer scientists, so it was probably a smart decision. And congratulations to Noam for the Knut Prize. Yeah, and he didn't actually, during these years, he never got to meet my father. And then between 1974 and 1979, he went to the army. In 1980, he married Mazi, and they have 3 wonderful kids, Neta, Chagai, and Lior. And in between 79 and 83, he did his PhD with Micha Perles, and in 83, he went to his postdoc in MIT. And the first time Gil met my father was in 1984. Interestingly enough, this was also the first time I met my father, so it's quite a coincidence. So they met in a farewell party that Silvio threw for Miki Ben Or, and Gil was 29 at the time, and he was wondering how come he never met Avi before. The interesting thing about it is that Miki never showed up because he got stacked on the way, whatever that means. Yeah, no, obviously stuck, but as Gil presents it, since he's not here, I can... Yes. And so the first time our families met was in 1986. I have a vague memory of this, although it doesn't make a lot of sense because I was probably less than 2 years old at the time. But we just moved from Berkeley to Israel and to Jerusalem, and both families were looking to buy apartments, and then they had this weird idea of buying a whole apartment building, 2 families that don't know each other. So I remember going and seeing it. I'm not sure you can take me for it, but anyway, they made an offer 2 days later, and we didn't end up living in one big commune, but it could have been interesting.
The late 80s and the early 90s in Jerusalem were truly wonderful from the point of view of our work and science. And here is an example of the vintage of 1 year for 1988. So here is 4 papers, among quite a few more, that Avi wrote in this year. So we can see the paper by Noam and Avi on hardness against randomness from Fox. The paper by Avi, Shafi, Joe, and Michael on multi-prover interactive proofs, how to remove intractability assumption. This was in stock. The paper with Shafi and Michael on non-cryptographic fault tolerance computing, and the paper of Avi and Maurizio on monotone connectivity, on monotone circuit complexity. And each of these papers really was the beginning of a wonderful theory and many subsequent developments. Quite amazing. This is amazing. You see, it's written there. It's amazing that these 4 papers were written in the same year by the same person.
Okay, so Happy Days Part 2, my high school thesis. And even in high school, when I was truly interested in math, when I decided what to do my thesis on, I was driven to the area of human behavior, and we decided on game theory. And the concept of Nash equilibrium was the basis of this thesis. So a Nash equilibrium is the most important solution concept in game theory. And for a strategic game, Nash equilibrium is a choice of strategies for players that for every player, deviating decreases their utility. So this is a very important concept, but what does it mean? We'll get to that. And a common interpretation of a Nash equilibrium is that it represents a self-enforcing agreement. So if people decide to play these strategies, they will not deviate from them. And so really what we did was ask if are all Nash equilibrium points really stable, and I'll talk about that a bit. So this is what it looks like. Was in 2002. I was exactly 18, and that's almost 15 years ago. Actually 14, whatever. So in a 1990 paper Uman published, he challenges the concept of stability in Nash equilibrium, or the fact that they are self-enforcing. And yeah, so we can just look at an example to try to understand this. So the orange is player 1, and the purple will be player 2, and they each have 2 strategies possible, and I'll say we're talking only about pure strategies and nothing like statistical here. Just either play this or that. And you can see that there are 2 equilibrium points, 7, 7. So if one of the players decides to deviate, he'll lose 7 points. And then there's another Nash equilibrium, which is if both play the second strategy, and they will each get a payment of 9. And it looks like a better choice for the players since they get a higher payment. But if we take into consideration the loss they will make from deviating from this point. So let's say player 1 decides to deviate, he'll lose only 1 point. But taking into consideration the risk that the other player might deviate, then he risks losing 9 points and his payment going down to zero. And then, so if he's not fond in risk-taking, he might decide to go for the safer strategy and promise himself a maximum of 2-point loss, or promising himself a payment of 7 and not risking getting nothing. So this is where the instability comes in. So actually, if by deviating you'll lose a small amount, an epsilon of what your original payment is, and the risk of losing a lot exists, then we're talking about unstable Nash equilibriums. So the research questions that we asked are, first of all, find some additional natural examples for this, and we did. I won't go into that. And then, so Gil asked me if we can always find one stable Nash equilibrium, and my answer to that was no. And here we can see an example. So let's say we have drivers in the street, and we have three types of drivers: careful drivers that slow on green and go on and stop on red, lawful drivers that go on green and stop on red, and careless drivers that go whatever the traffic light says. And we just, I don't know, I came up with this payment. Yeah, it's arbitrary, but believe me.
Obviously, you did some experiments.
Yes, definitely. And I'm alive to tell about them, so. So here we have, we actually have two Nash equilibrium points, and both of them are unstable, taking into consideration what Uman said and what I explained before. I won't bother going into this, but I would like to give you another example for this from something closer to my world, and it's the ultimatum game that probably some of you know. And this is an experiment where couples are taken and each given $100. And the first player is asked to make an offer as to how to split the money between them. And if the second player agrees, I actually have, I have a slide. If the second player agrees, they actually divide the money. And if he rejects the offer, then both don't get a thing. And if you think about it, every point other than 100 to 0, the offer of 100 to 0 is the Nash equilibrium, because they both win something other than not getting a thing. But when this experiment was done, they found that people tend to reject any offer other than 50-50, and this is for psychological factors and personality traits that go into this. So once again, I think we proved that there's nothing rational about our behavior, and therefore.
If it's a huge amount of money, like $1 million, check it's 400.
Well, we're talking about 100. If you,
This wasn't tried
yeah, if you're willing to try, I'm willing to participate in the experiment. Yes. So, and another. So we were looking also for an example only with one Nash equilibrium with the same problem, with the instability problem. We could not find one for a 2x2 matrix. I won't go into this, but we did for, we can go on with the traffic example and change the payments. And here actually the best, or the best strategy is for both players to be lawful. And this is a Nash equilibrium. And actually here, if you deviate from it, it's not that, I mean, well, basically you're risking your life. So this would be a reason to deviate. And yeah, I don't know, if you're afraid of a careless driver, then you would deviate from lawful and be careful. And I'll just give an example, a live example for that. So a few years ago, Amir and my dad were in Chicago going to dinner, and they were in a cab, and suddenly the cab driver like stepped on the brake, and they all whiplashed back and forth, and then they saw a car rushing. He had a red light, but he was just going very, very fast. So obviously, even if the cab driver was a lawful driver, deviating to careful saved their lives, and we're happy he did that, even if they were late for dinner. Yeah. So. And then another thing we did is formalize Uman's instability. It's possible to give it a mathematical formalization, but again, I won't go into that right now. Yeah, and just other things. This is the end of my project. I'm not going to read it, but I just say that I stated here how much fun I had, and that I'm sure I'll keep on going with this field of math and game theory, and as you can see, that's what happened. And just for the sake of it, a picture of Gil and Uman. And we'll go back to Gil for a while.
So let me move now to tell you about some mathematics. This mathematics happened with the help of Edna. So the story starts with René Descartes, many hundreds of years ago. And Descartes proved that every three-dimensional polytope has a two-dimensional face, which is either a triangle, a quadrangle, or a pentagon. And this of course follows from Euler's theorem, but Euler's theorem came about 100 years later. And Descartes came quite close to proving Euler's theorem. And we see that we cannot save any of these possibilities, because there are polytopes all whose faces are triangles, there are polytopes like the cube all whose faces are rectangles, and there are polytopes like the dodecahedron all whose faces are pentagons. And my theorem from 1990 shows that one dimension up, in 5 dimensions, every polytope contains a 2-dimensional face which is either a triangle or a quadrangle. And the 5 dimension is the best possible, because in 4 dimensions there is still a famous polytope called the 120 cell, all whose facets are a dodecahedra, and therefore all whose 2 faces are pentagons. But from dimension 5 and above, every polytope has a 2-dimensional face which is either a triangle or a quadrangle.
How did Edna help?
That's good. So this is a good question, and let's move to the next slide. I hope. So the general idea behind the proof is the following. You start with a large number of known linear inequalities for parameters of convex polytopes. So I should say, what are these parameters? So these parameters are number of faces of different dimensions, and a little bit more involved parameters which count chains of faces of various dimensions. And now you have a large number of parameters, and there are several inequalities which are known for them. And then when you want to prove a theorem, like the theorem I mentioned in the previous slide, you add to this system of inequalities also this theorem and all its consequences. And you hope that you will get a contradiction. And in order to implement it, you need some linear programming package, or you need to implement yourself some linear programming, complicated linear programming problems. And this is where Edna helped me in the initial result. And later I got very excited with this idea and pushed it further. First with Peter Kleinschmidt and Gunther Missinger, and later with Shachar Lovet, that before he became a famous theory of computing person, did his master on convex polytopes. And slowly we start with letting the computer prove theorems, and slowly we even let the computer make the conjecture on its own. So here is a conjecture that I made at that time. So this is a conjecture that I made and not the computer. And the conjecture is that for every k, there is a d of k, an integer d of k, such that every d polytope of dimension greater than d of k has a k-dimensional face, which is either a simplex or a cube. This conjecture is open for k greater than 2. For k equal to 2, this is the theorem I mentioned before. And it is open for k greater than 3, even if there are just a finite list of types of K faces that you can always guarantee if you are in high enough dimension. For K equals 3, Kleinschmidt-Missinger and I proved that every 9-dimensional polytope has a 3-dimensional face with at most 77 faces, and this have led to very surprising application. So Eyal, can you guess what application to what area?
I have no idea.
Guess, make some guess.
Theology.
Okay, let's see. So our proof that every 9-dimensional polytope has a 3-dimensional face with at most 78 edges have made it into art, a piece of modern art by Bernard Venet that you can see here. Here you can see the systems of inequalities that lead to the contradiction. And Bernard Venet is an artist, and he had a whole exhibition based on formulas that he found in mathematical papers, which are visually attractive. And our next slide will show actually his exhibition. So this is how Venet's exhibition of mathematical formulas look like.
So one of Gil's most exciting works is that in 1993, along with Noga and my mother, they managed to organize a conference in Jerusalem with 30 speakers, and 16 out of them were female. That's one of his greatest achievements, and he's very proud of it. Here are some pictures of our trips together. Not quite sure where it is, but anyway. And so in 1995, we were living in Princeton, and Yuval was about a year old then. And Gil was here for the semester, and we would go, I think, twice a week to have dinner in Sakura, get some sushi, and one of the nights Mike was with us, and for some reason he came with us back home. Mike Sachs, yes. And Gil decided to translate Yuval's favorite book of the time, Aye Pluto, a story about a dog, and he's very talented in this area as well, so let's just give an example of his translation. Pluto returned to the farm, to the house of the cows. "Hello, cow, do you make whipped cream?" "Stupid little fellow," the cow responded. "I manufacture milk for cheese." So.
Maybe this is the place to add that Gil's father translated Zorba the Greek to Hebrew.
Well, probably that's the inspiration, yes. Okay, and during that year, another nice thing my dad and Gil like to do is bet, and here's an example of a typical bet between them. So Gil calls my father excited and tells him he just saw on TV that OJ was acquitted, and my dad says, "This is impossible. I bet you $1,000 this is not true." And Gil tried to get him out of it and said, "It won't be right to bet with you, but since I'm seeing it live on TV," but my dad didn't mind and decided to bet. And this is only part of the huge amount of money he owes Gil by now. Okay, so this, I can't explain what's written here, so if you want, you can read it. I'll just say that as I was going with Gil over the talk, I was astonished to find out that Gil and my father have only one paper in collaboration, since I can recall numerous hours they sat together working. And Gil's explanation was quite simple. Probably if they wouldn't spend so much time betting, arguing, talking nonsense, translating kids' books, then they might have been more productive.
This whole story about faces of polytopes connects with a very recent exciting work by Avi and some collaborators. So let me remind you that a zonotope is the sum, or Minkowski sum, of line segments. And the faces of zonotopes are also, zonotopes and two-dimensional zonotopes are always parallelotypes. And a special case of Descartes' theorem is that every three-dimensional zonotope has a rectangular face. And this is essentially the Kalai-Sylvester theorem, which is a very famous theorem in discrete geometry, which says that if there are n points in the plane not on a line, then there is a line which contains precisely two of them. Now, recently, there is the following theorem, which is quite similar in spirit to the theorem for general polytopes that I mentioned before. And this is a theorem by Dvir, Saraf, and Wigderson, which improve an earlier theorem by Barak, Dvir, Wigderson, and Yehudayov. It gives a startling development, a startling quantitative version of the Kalai-Sylvester theorem. And in the language of zonotope, it says that every d-dimensional polytope, if d is large enough, in this case it needs to be larger than 12 over epsilon, containing an edge so that more than 1 minus epsilon of the two faces containing this edge are foregons or parallelotypes. And I should say there is a meta-conjecture which says that in some sense for general polytopes, a typical face of a typical polytope, a typical low-dimensional face of a typical high-dimensional polytope, or even a typical low-dimensional face of every high-dimensional polytope is in some sense combinatorially isomorphic to a cube. Where were we? Okay, so I want to tell you a little bit about another adventure related to discrete geometry and polytopes, and this is a little bit about diameter of graphs of polytope. And this story is related to things that I talked a lot with Avi, and it's also has some subtle connection with the photographer of this video, which is Eyal. So around 1990, I had a very ambitious program, and my idea was to relate, on the one hand, the theory that I was mainly occupied with at that time, which is face numbers of polytopes and related algebraic combinatorics, alas Richard Stanley, and to apply it to show a polynomial upper bound for diameters of graph polytopes, and perhaps even polynomial pivot rule for the simplex algorithm. And the way to connect between the two areas is using expansion and rapid mixing and all the stuff that all my friends Noga and Alex and Avi were talking about quite a lot. Before I continue, let me just mention that you see, Avi tends to dress casually, and I always had the temptation to dress more formally, especially I really like jackets, although many of my Israeli friends don't like it. And actually, one thing I discovered after 30 years I had lived in complete misconception about jackets. I thought for about 30 years that many jackets, because they are inexpensive, they have fake pockets. You see, like this jacket, that you cannot put your hand in the pocket. They have fake pockets, and just this allows them to sell them cheaply. But then I had some casual conversation with some seller at a jacket shop in England, and actually this is a hobby that both Avi and I have, to start to talk with people in somewhat unexpectedly, and he explained to me that actually this is not a fake pocket, but you can just open it with a scissor and it will become a real pocket. And I really went home and looked at my 30 years old jacket, which was all torn, and the pockets were completely genuine. Okay, so now I don't know if this will be part of, if you will see this part, but now let me move to my 90 paper, which was meant to implement this program. And this was a very nice paper where I managed to push a little bit on the left side the phase number and algebraic combinatorics theory, and I had some nice ideas on the right part on polynomial upper bound and various randomized pivotal rule, but the gap between these two areas was still very wide, and I had to move to plan B. And plan B was just to try to solve these problems, diameter of graphs of polytopes, pivot rules for the simplex algorithm using elementary combinatorial tool. And these have led to a quasi-polynomial upper bound for the diameter of graph of polytopes. And we returned quite a few times to the problem. And I tried to solve it and for many years. And this is actually related to you, Eyal. Do you know when we had our best choice, almost succeeded in proving this problem?
No idea.
So we almost succeeded when Eyal had some operation, and we were waiting in the waiting room. But then the operation ended as scheduled, everything was okay, and our efforts were interrupted, and we didn't solve the problem. לא יודע אם זה...
Okay, I think they want me to finish, so we'll skip this. And just a bit of our future plans. So Gil has some startup ideas. And so a few weeks ago, I went to have lunch with my dad in Tel Aviv in his favorite cafe, which unsurprisingly is Gil's also favorite cafe, and we met. We didn't plan to meet, and we sat together for a few hours. And during this meeting, he started talking to me about my high school thesis because he wanted it for today's talk. And he asked me how it was. And this subject has not been mentioned between us for the last 14 years. And I actually revealed what a tough experience it was for me. And yet, surprisingly enough, a few nights later, I dreamt that I'm doing my PhD under Gil's supervision. And it was, so I have a subject already ready, and I dreamt we were creating some game theory model to try to explain suicide. And I shared this thought with Gil, and he was actually very excited about it and almost filled the forms up for me. So I might be enlisted in the Hebrew University by now, but anyway, so now we are talking about this. But following the introduction to this talk and the fruitfulness of Avi and Gil's collaboration, don't hold your horses. Maybe it will work and maybe not. And happy birthday, Abba. Thank you.